Here's a vector example to consider that is a little bit more complex. So you're working one day as a wildlife biologist tracking the movement of a lion. Lion undergoes several different displacements during a week. You have 12 kilometers west, followed by 6 kilometers at 12 degrees north of west, followed by 2 kilometers, 55 degrees north of east, and then finally 5 kilometers east. So you have to combine these different vectors. Well, you're going to start drawing a starting point, kind of eyeballing. We're going west, we're going east, and a couple of norths, one north of east, north of west. So I want to give myself some room to the west and some room to the north. So I'm going to start my starting point right around here. Okay, first vector, 12 kilometers west. Relatively long compared to the other ones. And there's my 12 kilometers. Now, followed by 6 kilometers at 12 degrees north of west. So from here, that's west. I want to rotate 12 degrees north of there, and then I have a vector half as long. So right about there, and that would be our 6 kilometers. Followed by 2 kilometers, 55 degrees north of east, so from the tip of this vector, east would be right there. I want to rotate 55 degrees and a very short vector, 2 kilometers, and then lastly 5 kilometers straight to the east. Resultant goes from start to finish. So then the lion at the beginning of the week started here. At the end of the week started there. That is our resultant. Now, looking at this figure, well, it's not a right triangle. It's not even a triangle at all. So we can't use Pythagorean theorem, the trig functions as it stands. Our goal is, similar to the other examples, to make this into a right triangle where, again, R is a hypotenuse. So let's consider the diagram in a little bit different fashion. First, we're going to draw each of the vectors head to tail. So the 12 kilometers west, followed by the 6 kilometers at 12 degrees north of west, followed by the 2 kilometers at 55 degrees north of east, and lastly the 5 kilometers east. Now the resultant goes from beginning to end, and we want that to be the hypotenuse of a right triangle. So then we're going to draw in x2 and y2, the components of the 6 kilometers, and x3 and y3, the components of the 2 kilometers. We want to take those and combine them. So now I'm going to pull the resultant over, and now the x components all pulled over, head to tail, the 12 to the west, followed by the x2 value that you would have found by trig, followed by the x3 value, which is in the opposite direction, that would be a subtraction, and then the 5 kilometers head to tail. That gives us the x total. Now, bringing over the y's, both of those are upward, so those end up with an addition, and notice how that combination gives us the right triangle where R is the hypotenuse. So then, to be able to do that, we're going to have to find the x and the y components of the 6, the x and the y components of the 2. The 5 and the 12 are already resolved down. So I'm going to draw out each vector individually, a little bit abbreviated in length. There's our 12 kilometers. It is entirely in the x direction, and it has no y component. Then we have the 6 kilometers. And again, our 12-degree angle here. And it does have an x, we'll call that x2, and a y2. Now this is a little right triangle, so we can use our trig functions on this. So if I go cosine 12 degrees, adjacent over hypotenuse, x2 over 6, sine of 12 degrees, opposite side, y2 over 6. Then we can calculate those values, and we'll get those in a second. Our third vector, let's see, we are 2 kilometers, 55 degrees right there. And so we have an x3 and a y3. This is also a little right triangle. So then trig functions, cosine 55 degrees, that's going to be x3 over 2. Sine 55 degrees, that's going to be y3 over 2. And we can do the calculations on those in just a minute. Our last vector is the 5 kilometers to the east. That is all in the x direction, and there is no y component. So then, doing the calculations on our middle vectors here, for the x we get, and I'm just going to kind of squeeze these in here, 5.87, 5.87 kilometers on this one. Let me get rid of our 5.8 there. Okay, and then the y component right here, 1.25 kilometers. On our next one, this is 1.15 kilometers. And then here we've got 1.64 kilometers. Now, before we can proceed, we have to check the signs of different things. Well, the 12 kilometers is west. We're going to have to put a negative sign on that. On our second one, we've got a west and a north, so this will be negative, this will be positive. On our third vector, we're east and north. Both of these are going to be positive values. And then our last vector is east, so that's going to be a positive value. So now when we combine, if we total up, I'm just going to say x total, that's going to be a combination of all of our x values, negative 12 kilometers, combined with negative 5.87 kilometers, combined with positive 1.15 kilometers, combined with 5 kilometers. We're going to get a total in the x direction of 11.72. And that's going to be negative. In the y direction, I've got a couple of zeros and then a couple of values. So we've got a 0, a 1.25, a 1.64, and another 0. In the y direction, that's going to give me a total of 2.89 kilometers. So then these are our x and our y's. So then if we pull this r value, kind of redrawing it here, then what we've done is we have found the total in the x direction and the total in the y direction, not drawn to scale. My total in the x direction is 11.72. In the negative direction, my total in the y direction is 2.89. Now we have a right triangle, so now we can use our normal trig to be able to find our resultant. R squared equals 11.72 squared plus 2.89 squared. And then the angle we want to find is right there by our starting point. Tangent of theta is equal to opposite side 2.89 divided by 11.72. That's going to give us an R value of 12.07 kilometers. Vectors include directions, and our direction is going to be 13.85 degrees, and our angle starts at west, and then we have to rotate north to get to R, so it would be north from west or north of west. Now, as a side note, we could have started back here with this east and this west and done a combination, because this would be negative, this would be positive, and those are linear. We could have done a combination of those initially to get a -7 or a 7 kilometers west, and then drawn it with the 7 and the 6 and the 2. Either way, you're going to come out exactly the same. So if you start out with a figure that is a right triangle, you can go straight to Pythagorean theorem and the trig functions. If you start out with a figure that's not a right triangle or not a triangle at all, find the components when you're applying the trig method, combine the x's, combine the y's to make a triangle that is a right triangle, and then use Pythagorean theorem and the trig functions. Ponder physics.